All right, so we're going to go ahead and interpret function notation. First one we're going to look at is from a graph. So in example one, it says the cost in dollars to produce 1 watt of solar energy is a function of the number of years since 1977, labeled T. From 1977 to 1987, the cost could be modeled by an exponential function f. Here's the graph of the function. Number one, what is the statement f of 9 equals 6 saying about the situation? So first, in the context of the problem, what is this problem talking about? Well, it's talking about the cost in dollars, and the years, which is time. All right, so knowing that, which one is the cost and which one is time? So you now know that this is your time, which is T, and this is your dollar amount. So how do I put this statement into a sentence? So it's saying when T is 9, and what's T? The time, which is the number of years since 1977. So there are two ways we can say this. 9 years after 1977, or you can actually do 9 years after, which is 1986. So let's go ahead and write that. So 9 years after 1977, which is going to be, what's 9 years going to be? 1986. Okay. After 9 years, the cost in dollars to produce 1 watt of solar energy is 6. All right. So the cost to produce 1 watt of solar energy is $6. Okay, so once you've labeled that this is T and this is the dollars, you just have to put it in the sentence that it's using. Example 2, approximately what is f of 4? So again, what does 4 mean? 4 is the time, right? So this is saying when time is 4, what is the dollar amount? So we know that time is years since 1977. So when the time is 4, the Y dollar amount is right here. So let's see if we can break this down. This is going 0, 20, 40, 60, 80. So what is half of 20? 10. Half of 10, 5. So each box is going 5, 10, 15, 20, 25, 30, 35, 40, and so forth. So each box is 5. So what is 4? It's 1 box over, so that's going to be 25. So this one is 25. What's 3.5? So this is 2, then goes 4. 3 is in the middle, and 3.5 is in the middle of that. So it's right here. Approximately, it's just below, so it goes 25, 30. So it's after 25, below 30. So we can say approximately 29-ish. Okay, so it's approximation. What do these values represent in context? So let's put this sentence down. We're going to write both of them at the same time. So what does this mean in context? It means in 1981, which is 4 years after 1977. So this is the year since 1977 plus 4. So 77 plus 4 is 81. So in 1981, or I'm going to say slash because I'm doing this one too. 3.5 years is going to be 77, 1980.5, or we can say in 3.5 years or in 3.5 years. Years after 1977, the cost of producing 1 watt of solar energy is, so it was $25. And in this question slash, this one was about $29. Okay, so what does it mean in the context of the problem? Okay, all right, number 3, when f of, I don't know the time, but when f of some time is equal to 45, approximately what is T? So this time you don't know time, but you know the dollar amount. So I'm going to go to the dollar amount, which I need 45. Each box is 5, so 45 right here. And T at 45 is going to be equal to what? 2. So at f of 2 is equal to 45 is a sentence. All right, so T is equal to 2. I guess I'll write it right here. T is equal to 2. What does this represent in context? So again, 2 years a couple of ways you can say 2 years after 1977, or we can just say the year. So 1977 plus 2 is 1979. So we can say in 1979, the cost to produce 1 watt of solar energy is, and what is it equal to? $45. Okay. All right. Example 4, question 4 looks like, question 4 looks like it goes with example 2. So that's all the questions are from a graph. I'm going to go ahead and answer from an equation, and then you guys are going to do the other 2 questions. So this is from an equation. So we did from a graph. Now from an equation, what is function notation? The area covered by a city in square miles is a function of A, of the number of years. Okay, so what are my 2 variables? So years is time, since the city was surveyed in 1980. All right, and then the Y is the area in miles, in square miles. Okay, so they give you the equation. Okay, the equation is this. It defines the function A. Number 4, I'm going to keep going in order. What does A of 0 mean in this situation? So they're saying A is equal to this. What does it mean when they put a 0 here? So again, what is 0? 0 is the years. So how many years have passed since 1980? 0. What does that mean? That is, remember, my initial, my start. So this is my initial start. And in this context, so that's what it means by definition. But in this context, it means when, and again, a couple of ways we can say this, when the area covered by a city was first surveyed in 1980, that's what it means, or before any time had passed after the city was surveyed. Okay, that. So we're going to write it as in 1980, the area, and you're just using the words in the question, covered by a city is, and what is it? So when it's 0, when the time is 0, so when I come right here and I put a 0 right there, put this in a calculator, that's gonna be 1 times 20 is 20. So it's gonna be 20. Right, so you just put in a calculator, but you can just believe me because I don't want to put it in. 20 square miles, so miles squared. Okay, so again, the sentence can change. It's okay as long as you can tell me what it means. What is A of 5? So what does that mean? The time is 5, right? So how do I evaluate that? And this time, since I am going to plug it into the calculator real quick, all right, so I'm going to take the question and type it in. So it's 20 parentheses 1.1 shift 6 x. So you can make this 2 ways. You can do this, right? You can evaluate functions. You can make it a table, and here are my functions. So there's 0, that's 20. If I want 5, I can just change the number to 5, and that's going to give me 32.2102. Or I can just come in here go to the x and just change the x to 5, and you're going to get the same number, 20, same number. So whichever way you want to do it is okay. All right, so what is A of 5? A of 5 is, and what is this talking about? The area covered in square miles. Okay, so can you have a decimal mile? Absolutely. So we're going to keep the whole answer. So 32.2102 square miles. So miles squared. All right, what does it mean in this situation? So again, just describing in words, what does this mean? 5 years after 1980, the area covered by the city in square miles is 32.2102. Or you can actually say in 1985, in fact, that's what the one I'm going to use. So let's go ahead and do that. In 1985, and where do I get the 85 from? I'm adding 5 to the 1980. So in 1985, the area covered by a city is 32.2102 square miles. So all we're doing is just writing it in function notation. All right, last question before you guys practice. When AX equals 43, so this time they don't give me the time, but they give me what? What is the other thing equal to? The area covered in square miles. So they give me 43 is the area covered in square miles. Approximately, what is X? All right, so if I have this answer is going to be whatever my equation is going to be 43. So I'm looking here to see 43. So I'm just going to keep pressing enter. Okay, it's not going in order. So let me make it go in order. So 2, enter, 3, enter. It should start picking up, but I guess if not, you're going to keep typing it until you see 43. So I'm just typing 10. Okay, so I passed 43. So I'm looking for 43. All right, which one's closest to 43? We got 42.87. This is it. So just after 8 years. Okay, so it says approximately, right? So it's not 8 years, but it's just after 8 years. So approximately what is X? X is approximately, and the way we write that in math is doing the little curve equal sign, is approximately 8. It doesn't mean it's equal to it, approximately. All right, so what does that represent? So after 8 years, actually we should say approximately because it's not equal. After approximately 8 years, okay, which is what, 19, so this is 1980 plus 8 is 1988. Okay, after approximately 8 years, the area covered by a city is 43 square miles. And you can write square miles or you can write miles squared, the same thing. All right, now that we've gone ahead and done both interpreting a function from a graph and from an equation, I want you to go ahead and practice you as well. So this one is from an equation and this one is from a graph. Let's practice. Let's practice.